All right, if a piece of wood is with a density of 530 kilograms per cubic meter is tied to the bottom of the pail, because of course this would float, right? Well, the density of water is 1,000. This is 530, right? And so we want to know what's the tension in the string. So what I'm going to do is the tension in the string will be the difference between the buoyant force and the weight, right? So the weight of the object is just m times g, right? Which is going to be what the density of the object times the volume of the object times g, right? And I'm using the density formula here, right? So mass is just density times volume. So 530 kilograms per cubic meter, right? Times 0.05 times 0.04 times 0.04. So turn these into centimeters first. Let me just say that, right? Times 9.81. Okay, so 530 times 0.05 times 0.04 times 0.04 times 9.81. And that downward force is 0.415944. And that's down, right? Okay, and then the buoyant force is going to be the density of the fluid times the volume of the fluid displaced times g, right? So that's going to be 1,000, because the fluid is water, right? 1,000 times the volume of the fluid displaced is the same as the volume of the wood, right? This is Archimedes' principle. So 0.05, 0.04, 0.04 times 9.81. So let's see. I'm so lazy, I'm actually going to go up and edit this previous entry here. .78, 0.7848 up, right? Well, let's set up an equilibrium expression in the y direction, right? So now we've got some unknown force. That's the tension in that thing, right? Plus 0.7848 minus 0.415944 equals 0, right? So in the y direction, they all have to add up to 0. So some unknown force plus the buoyant force minus the weight is 0, right? Well, do you see that it's just going to be the tension in that string is going to be this minus this, the opposite of that, right? So I get that force is 0.3688 newtons. It's negative, right? Which is, of course, I didn't say what force in what direction, right? But that would be the tension in there, right? Ta-da. Or you can just, by the way, you can just go this minus this if you find the equilibrium expression confusing.